Hello Chemistry and Society class, my name is Mariella DeTavio and today I will be presenting on the topic, the chemistry of lakes and the effects on the ecosystem. So first I'd like to talk about some lake chemistry. So biotic influences, those are influences that have anything to do with the natural course of the world. So photosynthesis, a process that aquatic and terrestrial plants go through, where they use energy from the sunlight and create oxygen as a byproduct. This is important in lakes because the oxygen that they produce becomes a primary source of dissolved oxygen in the water. This is very important for various animals. I'll also talk about pH and salinity. So pH refers to the acidity or the basicness of anything. So in this terms, we're talking about a lake. And it usually correlates directly with a salt content. So a neutral lake will have a pH of approximately 7, and that's right in the middle from a scale of 1 to 14. An acidic lake will have a pH that is less than 7, and a basic lake will have a pH that is greater than 7. Chemical compositions of lake water. So different lakes from around the world will have different compositions. So you'll find that a lake near an ocean will have a lot of sodium and chloride ions found in the water. This is because it's from the ocean spray. Common chemicals found in lakes that we can find here in Manitoba would be calcium, magnesium, potassium, sulfate, and silica. Also another crucial part of the chemistry composition in a lake is the sedimentary water layer. So that has a lot to do with dead plant material. So as plants decompose, phosphorus and organic materials end up lying at the bottom of the lake. And they're usually only disturbed when there is a seasonal turnover and they get mixed back into the lake. So the use of our lakes. So many Manitobans love going out to the lake. So Lake Winnipeg is the second largest watershed in Canada. So when all the snow melts in Winnipeg and around Manitoba, it flows back into the lake and that prevents a lot of flooding. It's good water for agricultural use, habitats for plants and animals, which I will be talking about, recreation, fishing opportunities, and hydroelectric power. Winnipeggers also know about Shoal Lake because that's part of the Greater Winnipeg Water District Aqueduct, and that is where Winnipeg and surrounding towns, where we get our fresh water from. So Lake Winnipeg's a big lake, so bigger lake, bigger problems. Due to the increase in pollution by human population, the lakes are actually suffering a great deal. So runoffs from farms where pesticides are used, they directly run off right into our lakes, and that's usually large amounts of phosphorus and nitrogen. This causes the water quality in the lakes to drastically diminish, and it's actually very hard on the animals and the plants that live in the system. So first one I want to talk about is E. coli bacteria. So it's a rod-shaped bacteria and it's normally found in the lower intestine of endotherms. So this is any warm-blooded animal, usually a mammal. It causes sickness. First, it disrupts the natural flora in the system of the body and usually the gut flora. It can cause infection and very high fevers. So who's E. coli? What's it really affecting? People to begin with. Anytime you jump in a body of water that's affected with E. coli, especially if you have an open wound, it will get into your system. Even if you eat meat or any kind of food that's been tainted with E. coli, there's a good chance you will suffer with it. Domestic animals, for instance, a lot of people's dogs go run into the lakes. They are very susceptible, being warm-blooded animals, that they will catch E. coli. But really the problem is when E. coli is affecting the lake wildlife, shoalbirds and other animals that use this water constantly. They live in it, they drink it, it's their whole livelihood. They're the ones that are getting sick. E. coli is usually curable very quickly with medical assistance, so humans and domestic animals can recover from it. The problem is lake wildlife don't have access to any doctors, so they usually don't recover. So another toxin I'd like to talk about in the lake is blue-green algae. It's a type of cyanobacteria. So if any of you have ever been around Lake Winnipeg or any of the other lakes in the summertime, you'll notice huge green globs all over the water. This is blue-green algae blooms. So basically they're large concentrations of nitrogen and phosphorus that spill right into our lakes. During the summer, where the sun concentration is higher and where the winds are a lot slower, it's the perfect growing opportunity for blue-green algae, and they thrive in this environment. What's the problem? It wrecks the oxygen dynamics in the lake. So high concentration of algae in the lake essentially will suffocate. And what I mean about that is as these algae blooms start to decompose, their decomposition process eliminates the dissolved oxygen that's in the lake. The lake can then go into something known as hypoxia, where basically the lake is suffocating, and as it's suffocating, anything else that's living in it will too. Fish no longer have oxygen in the water to be able to breathe, and they start dying off. So acid rain and pH balance. So acidification is a major problem that happens in our lakes. Acid rain is a chemical reaction between something such as sulfur dioxide or something such as nitrogen dioxide, and usually reacts with other reactants in our air. This is usually caused by the amount of pollutants that we as humans send into our atmosphere. So acid rain pours down into lakes and it pours down into rivers. Usually lakes have a way of coping with this, known as buffers, which I will talk about. But some lakes don't cope with it very well. So a lake that now has a pH of 7 will then later, due to acid rain, have a pH all the way down to 4, which is extremely acidic. So effects on our animals, basically what we've been talking about. So aquatic species, lakes usually have to deal a lot with fish. So chemicals in the water that have been found in lakes in Alberta have proven to cause disasters to fishing populations. Fish, for example, such as walleye, have been caught with extreme deformities, large eyes, and tumors. Fish also are unable to spawn properly because they're oviparous, which means they have their eggs outside of their bodies and it's in the lake, so the acidity and the pollution in the lake is not good for them to reproduce. And acid rain can cause them to die. Land species. A major thing that's happening with the pollution in land species is something known as atoxin A. It is a compound that's found in blue-green algae, and it attacks the central nervous system of animals. So ecologists have found that it's been a factor in many deaths in animals, including deers, moose, beavers, and also lots of wildlife. Also a huge problem is physical toxins. People throw in their garbage and biohazardous wastes in the lake system. These animals will use them and they will get sick from them. So here I have a lake pH chart, so how species are affected. So going back to the lake that was at a pH of 7 and goes to a pH of 4. If we look at pH of 4, the only thing that's surviving is frogs. Everything else has been wiped out. Essentially all the ecosystems in this lake have been wiped out. Realistically, the frogs have nothing to eat and nothing that's going to eat them. They are going to die as well. So effects on plants. So lakes are home to an abundance of plants, from angiosperms to conifers. Luckily, plants are quite a lot more resistant than animals are, yet they are totally not ineffective. So lakes have changed from allotrophic lakes to eutrophic lakes with the appearance of humans. So increases in plants, so that's more plant competition causes less O2 sometimes in the water because it'll spike up all at once and then it'll fall all at once as well. There's huge competition within plant species. An invasive plant species can come into the lake, it grow, and then it take out all the common plant species. This can cause restriction in fishing areas due to the amount of plants, seaweeds, or algae that fishermen can't collect any fish due to the increase in the plants. So the burden on our ecosystem. So lakes provide us with so much life. So with population, with pollution, the lakes are truly struggling. So I like to use one example. So take a fish. We could take any fish, a perch fish, for example. Due to the pH or pollution or whatever you have it, this fish is no longer in the lake. So the secondary feeder that feeds on this fish now has run out of food. It has two options. First option is it can search for other food. The problem with this is it causes it to expend energy from its energy budget. It now has to search for food, and it has to make sure that the food it searches for is going to be equivalent to the energy that it lost. Sometimes this is extremely hard for animals to do, and if they don't do it, they're very likely that they're not going to survive. Second thing, it can encroach on another animal's territory. A lot of times territorial battles happen, one animal or both animals become hurt, and no one's really a winner in the end. So now all of a sudden it's going from one animal being gone in an ecosystem to now two animals being gone in an ecosystem, and it can increase. Here's just another chart relating to acidity, how low acidity, fish will die, high acidity, fish are also going to die. 6 or 7 is perfect. So how do some lakes cope? So many lakes around the world aren't affected by these problems. So like I said, I was going to talk about pH buffers. So lakes that have a large amount of bedrock sediment, such as limestone, carry a large amount of calcium carbonate. This acts as a buffer. Basically, calcium carbonate will dissociate into the water into its ions, calcium, and then to carbonate. Carbonate will then attach onto an acidic proton, which is the H positive proton, and it will neutralize. So it will then go back to, instead of being an acidic, it'll neutralize it to go back to more of a normal pH. Ecosystems have their own coping mechanisms. Halophiles are organisms that last in acidic and salty environments. They're quite small, but they are very important to ecosystems. Marshes and wetlands, these are known as the kidneys of the lake. They surround lakes and they absorb toxins and they take them out of the lake so the lake can stay healthy. And even animals. Beavers are known as ecological engineers. They will create dams that prevent toxins from floating into the lake. So how can we help? So just be conscious about what you're throwing away. Make sure it's not something that's gonna end up in the lake. Don't disturb ecosystems. Don't pick up plants from there. Don't pick up animals. You could be, taking an important niche out of its area. Use biodegradable cleaning products. A lot of people don't think of this, but any cleaning product you use, you're gonna wash your car with, can end up in our groundwater and then into our lakes. Conserve water as often as possible and educate others and yourself. So especially, talk to people about the problems that are happening in our lakes, and hopefully we can all come to a resolution that'll help save our lakes and make them a little healthier. So that's the end of my presentation. Thank you so much for watching.